solve one more example using the concept of accelerating reference frames, where we make use of concept of pseudo force. Now in this question, there is a lift which is accelerating up with 2 meters per second square, and this is a massless pulley tied to the roof of the lift elevator, and there are two masses hanging, 10 kg and 20 kg. All the things, they are idle. This is massless, string is there, this string is idle, and this is moving up with 2 meters per second square. We have been asked what is the value of tension in the string, and we can solve it. Let's solve it using accelerating reference frames. As now our aim is primarily to use non-accelerating reference frame, so what we do is we shift our observer who is on the ground, and he was making an initial reference frame, and we make him stand in the lift. Now lift is going with 2 meters per second square, so now he is also going with 2 meters per second square upwards. So now he is making a accelerating observer or non-initial reference frame or observer. Now if he wants to find the value of tension, he has to fulfill few requirements. Number one is, that is, he cannot disturb the original forces, actual forces, real forces which are acting otherwise also. What we see is, that is, there is a m into g, taking g as 10 meters per second square. For the ease of calculation, earth is applying a force of 200 Newton in this direction, m into g, m is 20, g is 10, 200 Newton, and 10 into 10, that is weight of the body, 100 Newton. These two forces, they are being applied. Now because the observer is accelerating and he is observing these two blocks, so in addition to all the real forces, that is real forces, he will apply one more pseudo force, fictitious force, imaginary force, whose direction is opposite to the direction of acceleration of this observer. This observer is accelerating in this direction, so that's why he will apply pseudo force on both the blocks. It is not which way the block is going, it is primarily, that is, which way the observer is accelerating. Observer is accelerating this way. These blocks, they may be going anywhere, they may be going this way, that way, any direction, but the pseudo force will always be applied in this direction because he is accelerating in this direction. So the pseudo forces which will be applied to the blocks will be in the opposite direction. Onto this in this direction, onto this in this direction, both vertical downwards. Please do not confuse it, that is, this block will be going down, this block will be going up, so accordingly you change the direction of pseudo force. No, the direction of pseudo force is determined by the direction of acceleration of the observer, accelerating observer, and the magnitude of this pseudo force in this direction is mass of this and acceleration of this. Acceleration of this is 2 meters per second square, so it is 20 into 2 is equal to 40 Newton is the pseudo force onto this. Onto this, mass of this 10 into acceleration of this 2, that is 20 Newton is in this direction. So now this person has shown all the forces, he has added a pseudo force also, so now he is competent to apply laws of motion. So now what this person observes? This person observes that if this block has a acceleration a downwards, the same acceleration will be observed by this block in the upward direction. So along the string, let's say along the string, if we see the net force, this way is 200 plus 40, that is 240 Newton is this way in this direction, and this way it is 100 plus 20, that is 120 Newton is being applied in this direction. Along the string, the net force is 240 minus 120, this is the net force along the string. String is being pulled this side by 240 Newton and this side is being pulled by 120 Newton. So the net force along the string is 240 minus 120 is equal to total mass. This resultant force is responsible for accelerating both the masses, that is 20 plus 10, that is 30 kg into acceleration. So this is 240 minus 120 is 120 by 30 is equal to A. So A is equal to 4 meters per second square. So this person will observe that the acceleration of this block is 4 meters per second square downwards and acceleration of this block is 4 meters per second square upwards. Now we have to find the tension. Tension we can find as we have been finding in earlier cases, that is, you draw a circle, either you draw this or you draw on this. So tension is over here. So equation for this is T, because this is accelerating up, T tension minus downward forces. In the downward forces, you have to take care of both the forces. That is 100 plus 20, that is 120. So T minus 120 is equal to mass is 10, into acceleration. Acceleration is as observed by him. He has observed the acceleration of this block as 4 meter per second square. So this T comes out to be 120 plus 40, 160 Newton. If you wish to do for this, so the equation for this is, this will going down. So this is 240 minus T. T will be in this direction, always away from the body. 240 minus T, mass is 20, acceleration is observed, acceleration of this block is 4. So 240 minus 80 is equal to T. So T is equal to 160 Newton. You get the same answer. So answer is same.